Okay, this is just a quick video to start my little experiment. It's been a while since I did any kind of science experiment. What I'm going to be doing is putting four pretty basic types of optical media out into the elements. It's winter here as I'm recording this, so it's kind of rainy. Actually, it's rainy right now as I speak. So what I'm going to be doing is testing four really not very special brands of optical media. I'm going to be testing two products from Maxell, CDR, DVDR, and I'm going to be testing two from that I purchased locally. They were like $5 for a 50 spindle of each CD and DVD-R, so super cheap, is probably as cheap as you can find. And we're going to be writing this onto this one file, the backup for content creators video, onto each of these four different types of optical media, and taking them in after a week, and then doing the scanning using DVD disaster. So that's going to be number one, to check for bad sectors. And the second thing that I'm going to be doing is taking checksums. So I'm going to go into my quick hash here, and I'm going to quickly take MD5 and SHA-256 checksums, just of the only file that's going to be on all of these, which is going to be test optical 0124, this file. So that didn't take very long. That's the MD5. In fact, I may as well take it according to literally all of these. Part two of the experiment methodology is that I'm going to be creating a bit of ECC, error correction code, just in case some of these do end up getting corrupted, and maybe I'll put them out for more than a week. Maybe I'll put them out for a month. Figured I may as well go through all the possibilities while I'm doing this. So what I'm going to do is I'm not going to create parity data because I think this will be better doing the ECC. I think it's supposed to be more advanced. So I'm firstly creating an ISO image of the MP4. This will just take a split second. The ISO was created. It's about the same size as the MP4 that we're testing. Going into DVD disaster, then I tell it where the image is. Desktop, test optical, and I just need to find the ISO file between these two, file number 2. So I'm pointing it to the ISO, and then I want to create error correction data in ECC format. So I just need to tell it where to put that. So I'm going to go test optical again, and it's going to be called 250124 is the date of today. 250124 test media.ecc, and I'm going to be storing this test media. So I'm going to go create now. So it's creating the ECC data from the ISO to the ECC and creates a checksum, and then it corrects the data. I'm going to be storing this on my NAS, so it's going to be stored not on the actual media itself. So it says the error correction file has been created. Make sure to keep this on a reliable media, so I'll put that on the NAS. And we might be able to do a test verification and recovery using this tool. So now I'm going to create my CDs. I'm going to do this as quickly as possible. The idea here is to test weathering, so I'm not going to do them in any kind of protective, anything to make them more resilient, like a low write speed. I'm just going to do them on automatic using the Pioneer drive that I have connected that I arrived today. And I'm going to go for burn. I'm not going to do creating an image, or I'm not going to verify the written data either. 0124, so just 6 digits, and that's going to be the same volume name for all the media. And we're going to burn. Okay, so the first CD has burned, and something I'll do quickly for each of these is I'm going to just check the checksums immediately after burning. You can do this I'm using Quick Hash in Linux, but this is also available on OS and Windows. So the way to do this, or the way you can do this, is compare two files. It's just a GUI that makes hashing easy. So I'm going to point it to the backup for content creators file. And I can also point it to the file before it was burned on my local machine in the test optical folder. Or I can give it the point it to the checksum I took. But we can just do it like this the first time and click compare. And this just takes a little bit of time because it has to read through the whole MP4 file directly off the optical media. You can hear it just spurring up in the background, but we should hopefully get a match on these checksums. Here's a quicker way to do the process I thought I'd show as well. So this is the file option. So we're just reading calculating one checksum, and we can put the expected value here. So I just swapped over to SHA-256 to make this one a bit quicker. 250124. Give it the backup for content creators, and it's doing the hashing a bit quicker because it just did it, I guess. And then we just need to look at which algorithm we're using. It's SHA-256. And I'm just copying and pasting this off my Google Doc. I like this way of doing it a little bit better. Not that there is much of a difference because you get the percentage meter, so you can see how it's going. It doesn't really save much time because computing a hash from a local small file is relatively quick unless you're on super old hardware. This is going to be my first experiment in the aging process. I definitely want to do one on the MDisk. So yay, that worked. Expected hash matches the computed file hash, right? So we can just look at it here. This is the hash that came off the optical media. This is the hash that I took before burning the file and saved in a Google Doc. And we can see that they match. So we know that the writing of this file has been, the file started its lifetime at least uncorrupted.